One reason that molarity is so useful as a unit is that it makes it very easy to measure the amount of solute you have. As you know that moles is going to be equal to the molarity of that solution times the volume, as long as that volume is expressed in liters. And that works because you see we have moles per liter as our unit of molarity. If we multiply that by liters, we end up with moles. So it's a very useful factoid to remember that we can get moles of solute simply by multiplying molarity times volume expressed in liters. Now look at this problem. We want to know how much solute we have in a given volume of a certain molar solution. Well, we know we can get moles by multiplying these two numbers together, and then to get to grams, we simply determine the formula weight and use that as a conversion factor. All right, so here we go. We have both the volume and the molarity of our solution. So we start with 0.460 moles per liter, and when you're working through problems, always translate molarity to moles per liter. It's going to help your units work out. Then we multiply it by 1.75 liters, and that gets us to where we can cancel out units of liters, and we now know how many moles of solute we have. Okay, I've previously calculated the formula weight of that compound, so we can now use this in our problem. We know that 141.96 grams is equivalent to a mole, and we know a mole is equivalent to 141.96 grams. We're going to use the conversion factor with the units of moles in our denominator so they can cancel. So moles equivalent to 141.96 grams. That tells us that we're going to multiply by the formula weight in this case. We do our math, we end up with 114.2778 grams. Now we'll go back and do sig figs. We have 3 sig figs in this initial number, 3 sig figs here. This has 5. This is all multiplication, so we're going to be limited to 3 sig figs. Our final answer is 114 grams. This next question asks to calculate the molarity. So the molarity is going to be the moles of solute per liter of solution. So we're told we have 0.066 moles, and we're in 0.20 liters. So we do the division, and we end up with 0.33 moles per liter. Looking at the sig figs, we have 2 sig figs in both our numerator and denominator. So right now we have 2 sig figs in our answer. That's our final answer. Let's look at this next problem. We want to calculate the molarity of a solution by dissolving so many grams in enough water to make 340 milliliters of solution. So again, we want to get to molarity. We can remind ourselves that molarity is moles per liter. However, we're not given moles, we're given grams. So we're going to have to calculate the number of moles in this sample. We're going to need the formula weight of potassium thiocyanate, and that is 97.19 grams per mole. So we have our mass, and we're going to divide by 97.19 because that is the operation that allows us to cancel grams. So now we know the moles of our solute, but we don't know the liters of solution. What we do know is the milliliters of solution. So we can divide by the milliliters of solution and then do our conversion. So let's check our units here. We have moles surviving. We have milliliters canceling out with milliliters. And so our units that survive are moles per liter. That looks promising. So we do the math that's indicated. Everything on top is multiplication. Everything in the denominators indicates division. And we would end up with 0.012100485 moles per liter. Let's look at our sig figs. 3 sig figs here. This has 4. This has 3 sig figs. This is exact, so it's not going to affect the sig figs in our answer. Looks like we're limited to 3. So our final answer, 0.0121 moles per liter. For this next problem, we want to know the mass of our solute contained in a certain volume of a certain molar solution. So we can calculate our moles, and then from our moles, using our formula weight, calculate the grams. Okay, well, remember, we're always going to have to express our volume in liters if we want this factoid to work. So we start with 6.00 moles of HCl per liter, and let's multiply it by 500 milliliters. But we're going to have to do a conversion to liters. So if we look at our units thus far, we see units of liters cancel, units of milliliters cancel. We know how many moles of HCl we have. HCl has a formula weight equal to 36.46 grams per mole. We want to cancel out units of moles, so we multiply by 36.46. Do our last check of our units. Now we have moles canceling moles. We have units of grams in our final answer, which is promising. We do our calculation, and this comes out to be 109.38 grams. Looking at the sig figs, 3 sig figs, 3 sig figs. This is exact, so it doesn't impact our sig figs, and this has 4. So we can go to 3 sig figs. Our final answer would be 109 grams.